Good day, everyone. I'm Arvin Enriquez, your subject teacher for probability and statistics. With this video lesson, we're going to discuss the topic which is about locating percentiles under the normal curve. Our lesson objectives: at the end of this lesson, you are expected to find z-scores when probabilities are given and locate percentiles under the normal curve. So for our lesson introduction, there is a question here. Which of the following expressions are familiar to you? First, first honor. Second, top 5. And your third example is a score of 98%. So these are expressions of order. They indicate relative standing. So dealing with these expressions, we are dealing also with your relative standing. In real life, many people want to belong to a high level in terms of relative standing. So as you can see, your first honor, your top 5, a score of 98%, these are expressions of relative standing. So how can we relate this one to statistics? The normal curve can be used to show relative positions of scores. In statistics, we use percentiles to indicate relative positions. So for our discussion points, percentile for any set of measurements arranged in ascending or descending order. A percentile or a centile is a point in the distribution such that a given number of cases is below it. A percentile is a measure of relative standing. That's why a while ago I said that we use percentile to represent relative positions in statistics. It is a descriptive measure of the relationship of measurement to the rest of the data. For us to visualize more what is a percentile, so let's try to consider this situation. Having obtained a score of 85 in a recently concluded unit test in science, John wanted to know how he fared in comparison with his classmates. His teacher told him that he scored at the 90th percentile. This means that John's score is equal to or higher than 90% of his classmates. This is denoted as your P of 90 or your 90th percentile is equal to 85. Or we can read this one as the 90th percentile is 85, which is the score of John. As part of the discussion points, let's relate your percentile to your z-scores. A probability value corresponds to an area under the normal curve. Yes, it is. Because simply the area under your normal curve will represent your probabilities under your probability distribution. That's why we always check if your table is a probability distribution table by simply getting the sum or total of those probability. If that is equal to 1 or not, if that is equal to 1, then that will be equal to the total area of your normal curve. In the table of areas under the normal curve, the numbers in the extreme left and across the top are z-scores, which are the distances along the horizontal scale. That will be your baseline. The numbers in the body of the table are areas or probabilities. That's why in every z-score or z-scores, there is a corresponding value of area or probabilities under your normal curve. Then next, the z-scores to the left of the mean are negative values, and your z-scores to the right of your mean are positive values. So, all values at the left of your mean are negative values, and all values at the right of your mean are positive values. Thus, when we are given the area and we wish to find the corresponding z value, we locate the given area at the body of the table. If the exact area is not available, we take the nearest area. Then we look up the corresponding z value in the table of areas under the normal curve or z table. So as part of the continuation again of your discussion points, let's have this illustrative example. So our first illustrative example is that find the 95th percentile of a normal curve. Analysis. Your 95th percentile means locating an area before or below the point. We want to know what the z value is at this point. So as part of the solutions of our illustrative example and part of our discussion point, so let's deal with your steps, no, as a part of your solution. Your first step is that you need to draw the appropriate normal curve. So you need to draw a normal curve, then express the given percentage as probability. So we can convert this 95% to decimal by simply divide this 95% by 100. So 95 divided by 100 is the same as 0.95. So for number 3, you're going to split 0.95 into 0.5 and 0.45 because half of the total area of your normal curve is equal to 0.5. So 0.5 for the positive and 0.5 for the negative. So 0.5, I mean 0.95 is equal to 0.5 plus 0.45. So we split this 0.95 to 0.5 and 0.45 because your 0.5 will represent the half of your total area under your normal curve. For number 4, shade 0.5 of the sketch of the normal curve in step number 1. So the proportion of the area above is 0.8413. So as you look in your C table, so what will be the value that we can map in your 0.8413? So if your C is equal to 1, then your area is equal to 0.3413. So if we add 0.5, so that will be 0.8413. Now, refer to the table of areas. So this will be your C table. Locate the area 0.45 in the body of the table. So you're asked to locate your 0.45 in your table. So let's try to find the 0.45 using your table, or in your table, I mean. So this area is not found in the table. So we need to look for the area that is almost there. It can be greater than to 0.45 and less than 0.45, but these are areas next to, or these are areas before 0.45. It is between the values of 0.4495 and 0.4505 in your table. So using your table, so if you try to locate your 0.4495 and 0.405, then you can find these two values of areas. Now, in your step number 6, so find the z-score that corresponds to 0.45 on the leftmost column. Find C by interpolation as follow. So for step number 7, find the C value that corresponds to 0.4505. So that will be 1.65 there in your C table. So for step number 8, find the C value that corresponds to 0.4495. So that will be 1.64 as your C value that you can map to your area, which is equal to 0.4495. Now, in your step number 9, so you're going to find the average of the two C values. So we're going to add these two C values, 1.65 plus 1.64, and divide it by 2. So your resulting value from the average of these two z-scores or C values will be equal to 1.645. For number 10, locate your C is equal to 1.645 under the curve in step number 1 and make a statement. So since your C is equal to 1.645 is a positive value, when you say this C score will fall at the positive side or at the right side of your mean. So the 95th percentile, I mean, is equal to C is equal to 1.645. Then for step number 11, you're going to draw a line through under the curve in step number 1. Do this under the sketch of the curve in step number 1. So shade the region to the left of your C is equal to 1.645. Then describe the shaded region. Then if this is your normal curve, for example, so let's try to look or to put your mean first. That will be at your center. Then if we try to locate this one, your C is equal to 1.645. So it will fall here. So that will be a positive C scores. So shade the region. Sabi dito, shade the region to the left of positive 1.645. So means say we're considering this area. So this entire area to the left of your positive C will be considered to this one because it's being stated that we need to shade the region to the left of C, which is equal to 1.645. Meaning to say, the shaded region is 95% of the distribution. So that's how we make your statement from our uh, figure or graph using your normal curve. If we put your C, which is equal to 1.645, then we shade the region to the left of the C value. For example number 1, we're asked to find the upper 10% of the normal curve. For your step number 1, so you need to draw your normal curve here. So let's try to draw a normal curve. So my normal curve is not it's not perfect as you can see, but you can try in your own paper. Oh, you can draw your own normal curve. So for your step number 2, express the given percentage as probability. So we're converting this 10% to decimal. So we just simply divide this 10% by 100. So that will be equal to 0.1. With this respect to the mean, locate the upper 10% to the right of the mean. Meaning say, we're locating this 10% to the positive side of your normal curve. So if this is your mean, so somehow your upper, or if we locate the upper 10%, no. So we are looking for this area. So the positive side of your normal curve. For number 4, using the upper side of the mean, find the remaining area. So what will be the remaining area that we can map on this one? So 0.5 minus 0.10. So 0.5, that will be the half of the total area of your normal curve. So if we subtract 0.1, so that will be your 10%. So your resulting value is 0.4. Now, for step number 5, refer to the table of areas under the normal curve. So we need to locate the area 0.4 in the body of the table. So still, your 0.4 is not found in the body of the table. So we take 0.3997, which is the closest value. So we need to deal with the closest value to your 0.4. For step number 6, find the z-scores that corresponds to 0.3997 on the leftmost column, which is equal to 1.28 as your z-score that we can map to your area or probabilities, which is equal to 0.3997. So our z-score here is equal to 1 point or positive 1.28. So as the continuation of the solution for our example number 1, so for step number 7, locate your C, which is equal to 1.28 under the sketch of the curve in step number 1. So let's try to draw here a normal curve, for example. So let's try to draw a normal curve. So maybe my normal curve is not perfect, but we can visualize here. So your positive 1.28 as your z-score will fall at the positive side of your normal curve, and make a statement. So that is the upper 10% is above your C is equal to 1.28. So if this is your mean, so somehow your positive 1.28 will fall here. So that will be your 1.28. Draw a line through under the curve in step number 1. So we draw a line under your normal curve. Then now for step number 9, shade the region to the right of C, which is equal to positive 1.28. So we're considering this area. So this area at the right of your positive 1.28 as your C scores that we can map to your 10%, no? Then this will be your area that we're considering in this example. So describe the shaded region. So the shaded region is the upper 10% of the normal curve. So this will be your shaded region. So the shaded region is the upper 10% of the normal curve. I hope is that clear to all of you. So for activity number 1 under this video lesson, you're asked to find each of the following percentile points under the normal curve. So you're going to plot your 99th percentile, 90th percentile, your 68th percentile, your 40th percentile, and 32nd percentile. So for the summary, a percentile is a measure of relative standing. It is a descriptive measure of the relationship of a measurement to the rest of the data. And we use percentile in statistics to represent your relative positions. In the table of areas under the normal curve, the numbers in the extreme left and across the top are z-scores, which are the distances along the horizontal scale. The numbers in the valley of the table are areas or probabilities. So the z-scores to the left of the mean are negative values, while your z-scores to the right of your mean are positive values. Thanks for watching. Like, comment, share, and subscribe.